Welcome back guys. In this session, we are going to explore the 4 pillars of object-oriented programming. The 4 pillars are inheritance, data abstraction, data encapsulation and polymorphism. So let's get started. Before going to OOPS, let's discuss a simple statement where you are using class and objects. Let's take a simple example. 2 plus 2 is equals to 4. How this program is knowing that he have to add two numbers and show the arithmetic addition result. This is because both the 2's are from the class int, and inside int there is a definition that if both the object will use plus operator, then do the arithmetic operation and show the result. Similarly, this class also have definition for other operators. Well, we have directly jump into deep knowledge. Let's understand each part individually. Let's take an example of manufacturing a mobile. First step, the company decide the features that will be with the mobile. Then they create some blueprints by creating a process how to make this mobile. Using this template, they create lots of mobile. If we compare this mobile with OOPS operation, the feature presents the methods and the attributes that are going to be inside the class. Now the question arises, what is method? A method is a procedure or function associated with a class. As a part of class, a method defines a particular behavior of the class instance. A class can have more than one method and all the variables are known to be attribute. Okay, so this is the first step. And the second step, the blueprint we are creating is known as the class. This blueprint defines all the criteria and the processes of the class. Okay, finally, the mobiles that are manufactured using the blueprint is known to be objects of the class. This is how we can compare the mobile manufacturing process to our object-oriented programming concept. Now, let's see some of the differentiations between class and object. First, class is the blueprint from which objects are created, whereas object is an instance of a class. Second, class is a logical entity, whereas object is a physical entity. Third, class can exist without object, but object can't exist without a class. Fourth, class doesn't allocated memory when it is created, but each object has its own memory. Fifth one, class declared once, object can created many times as per the requirements. Now let's see an example of a simple employee class, where the class contains 3 variables, name, age and salary, but class have not allocated any memory with it. Now let's create 2 objects of the same class, initialize them with their values. As you can see, we have 2 employee objects having allocated with different memory location. Both objects are similar but not the same. We can access the value of employee1 object by employee1.name for accessing the name, employee1.age, employee1.salary. Similarly, we can access the value of employee2 by using employee2.name, employee2.age and employee2.salary. Remember, if we change any value of employee1, that will not be affect the value of employee2. So these are the fundamentals of class and objects. Now let's explore the first pillar of OOPS, that is inheritance. What is inheritance? The programming technique that used to reuse an existing class to build a new class is known as inheritance. Let's suppose we have a class A which have a variable named var1 and a method named method1. Now we want to create another class named class B which have the same variable variable1 and a method1 as class A. Addition to that, class B have variable 2 and method 2. Now the question arises, does you have to write the same code which we have written in class A again? No, This is where inheritance comes into picture. We can inherit class B from class A and use all the attributes and methods of class A. In this manner, we can make our code reusable. Now, let's see different modes of inheritance. First, public inheritance. In this type of inheritance, all the access modifiers of attributes are going to inherit as it is. That is, public attribute will remain as public, protected attribute are remain as protected, and private attribute are remain as private. If you are confused about the access modifier, then just understand private means only the same class has access to the members, public means everyone has access, and protected lies in between, where only derived classes have access to the base class methods. I will be uploading another video showing detailed description about access modifier. If you want, just let me know on comment section below. Now, next mode of inheritance is protected inheritance. In this type of inheritance, the public attributes are going to be protected in child class, but other are going to stay as it is. Finally, private mode of inheritance. In this type of inheritance, the public attribute and the protected attribute both are going to be private in child class, because we have inherited with private mode. That's all about modes of inheritance. Now, let's see the types of inheritance. First, single inheritance. In this inheritance, a derived class is created from a single base class. Second, multi-level inheritance. In this inheritance, a derived class is created from another derived class. Third, multiple inheritance. In this inheritance, a derived class is created from more than one base class. Multipath inheritance. In this inheritance, a derived class is created from another derived class, and the derived class have also a relationship with the base classes. Fifth, hierarchical inheritance. In this inheritance, more than one derived classes are created from a single base class, and for the child classes act as parent classes for more than one child classes. Sixth, hybrid inheritance. This is a combination of more than one inheritance, hence it may be a combine of multi-level and multiple inheritance, or hierarchical and multi-level inheritance, or hierarchical with multi-path inheritance, or hierarchical with multi-level and multiple inheritance. We can combine any combination and make hybrid inheritance. Now, let's explore the second pillar of OOPS, that is data abstraction. Abstraction means displaying only essential information and hiding the details. Data abstraction refers to providing only essential information about the data to the outside world, hiding the background details or implementation. You can think of basic example. When you are clicking the like button, you will see only like count increasing, but there is no idea how this is happening. Similarly, when you click on subscribe button, there also it is showing subscribed without any information how it is happening. You can test these buttons below this video. This mechanism is known as data abstractions. Similarly, our next pillar is data encapsulation. Data encapsulation, also known as data hiding. This is the mechanism whereby the implementation detail of class are kept hidden from the user. The user can only perform a restricted set of operations on the hidden members of the class. The user can only perform a restricted set of operations on the hidden members of the class by executing special functions called methods. We have a class with a private variable and a public method. Now we create an object of the class, and if we try to access the private variable directly from the object, then we will show error because we can't access a private variable from the outside. Now we can access the variable by using the method. This concept is known as data encapsulation. Finally, last but not the least pillar is polymorphism. The word polymorphism is a combination of two words, poly and morphism. Poly means many and morphism means forms. that is many forms. Let's take an example of a doctor. He have three roles. He is a doctor, he is also a father, he is also a human being. A single person having multiple forms. This mechanism is called as polymorphism. Polymorphism is divided into two parts. First, compile time and run time. In compile time, there are two types of polymorphism: method overloading and operator overloading. In runtime, there is one type, method overriding. Let's detail about them. Method overloading. When there are multiple functions with the same name but different parameters, then these functions are said to be overloaded. As you can see in the class A, there are two methods with the same name, but method 1 have one parameter, whereas method 2 have two parameters. These methods are going to identified by their parameters. This concept is known as method overloading. Next, operator overloading. As we know, plus operator is used to add two integers, but we can also customize this plus operator to work according to us. As an example, we can customize this plus operator to concatenate two strings. This mechanism is known as operator overloading. In this process, we overload any operator we want. Next, method overriding. When a derived class has a definition for one of the member function of the base class, that base function is said to be overridden. As you can see from the example, class A have a method named method1 and class B have also same method, but there is some change in program in class B. This is known as method overriding. This is all about the four pillars of object-oriented programming.